Functional groups in organic chemistry, presented by Science Visualized. Before we start, I would like to quickly introduce alkyl groups, and we're going to be using the letter R for that. So R means alkyl groups. For example, if this group here is broken off at this position so that you have this group as a substituent, so it will have carbon 1, 2, and 3 carbons, so that becomes a propyl group. This one here has 1, 2, and 3. So if it's attached to something else, that becomes a 2-propyl because the substitution is at position 2. So 2-propyl alkyl group. This one here has 6 carbons, so it becomes cyclohexyl. This one here is a benzene ring, has a benzene ring attached to something else, and that's called a phenyl group. So phenyl group, or phenyl with a Y, not O. So all those are alkyl groups. There are so many different types of alkyl groups, and from now we're going to be using R to mean any type of alkyl groups. Okay, now with that, we're going to introduce functional groups. There are so many different functional groups in organic chemistry, and same functional groups will participate in similar kind of reactions. So it's very important to know functional groups because it affects the reactivity of the molecule, it affects the stability of the molecule, it affects the geometry, the shape of the molecule. The first functional group we'll look at is alkanes, and that's basically carbon with hydrogen and no double bonds or triple bonds. So we'll denote that by using RH. So an example of that will be just like a straight chain alkane. Alkenes have one double bond. They also contain carbon and hydrogen only, but they have at least one double bond. So I will use that as an example. And an example of that will be something like this with a double bond. Alkynes have triple bonds. An example of that will be, now remember, triple bond is sp hybridized, so the bond angle has to be 180 degrees, and that's why we draw it to look like it's straight like that, because it's an sp hybridization that has bond angle of 180 degrees. Next, we go to alcohols, and that basically contains an OH group attached to a carbon as part of an alkyl group. So an example of that would be something like that, OH. Alkyl halides have an alkyl group with a halogen. Remember, the halogen can be fluorine, chlorine, bromine, or iodine. So alkyl halides. Example of that would be something like this. Amines, they have an alkyl group with a nitrogen with 2 hydrogens, or nitrogen with 2 alkyl groups, or nitrogen with 3 alkyl groups. So this one here will be a primary amine, but you can also have secondary or tertiary amines. So an example will be that will be a primary amine. Ethers have an oxygen between 2 carbons. So you have R or R. You have 2 alkyl groups on either side of the oxygen. So an example of that would be something like this. So that would be a symmetrical ether because the R group here and the R group here is on this other side are similar, but you can also have unsymmetrical ether like that. Peroxides, they have OO bond. So they have carbon, oxygen, oxygen bond. So for example, OOR, so that's peroxides with 2 alkyl groups on either side, or you could have something like hydrogen peroxide or other types of peroxides. That would be a peroxide. Sulfides, you could have SH, that would be a thiol, so like an alcohol, because sulfur is in the same group as oxygen, group 6A. And because of that, they tend to have similar type reactions. So this would be almost like an alcohol. It's called a thiol, SH. An example of that will be, or you could have a sulfide where you have the S between 2 alkyl groups. So that will be almost like what we have here as ethers, but now for sulfides, you have something like this, S, so that will be a sulfide or a sulfur ether. Next, we go to carbonyl functional groups. These are functional groups that contain carbonyl. Carbonyls are carbon-oxygen double bond. These are also very important functional groups in organic chemistry. The first example is an aldehyde. What I usually tell people is L, focus on the L. The L looks like this, uppercase L. So aldehyde will look like an L either that way or an L facing backwards. So in this case, this will look like an L facing backward because we ignore this other position because we have a hydrogen there. So that's an aldehyde. So in aldehydes, this position has an oxygen just next to the carbonyl. You have one R group and a hydrogen on this position. A ketone is very similar to an aldehyde, but now instead of a hydrogen, you have another alkyl group. So an example of a ketone will be that. You have two alkyl groups, or you could have a cyclic ketone, like that. So that you have an alkyl group on this side and an alkyl group on this side that's joined to make a circle. And then this would be an example of an aldehyde, like that, or you could just draw it like that without having to show the hydrogen. Next is acid halides. Acid halides have an R group joined to a carbonyl, and then this position has a halogen. Remember, halogens could be fluorine, bromine, chlorine, and iodine. So an example of that would be, so something like this. This would be an acid fluoride. So you could have acid fluoride, acid bromide, acid chloride, and acid iodide. These are actually the most reactive type of carboxylic acid derivatives, and we'll see that later. Carboxylic acids. These ones have an OH at that position. So an example would be something like that, OH. Esters, they have an OR at that position. So an example of that would be something like this, OCH3. You could also have cyclic esters. So this would be a cyclic ester. Amides. Amides have the carbonyl group, and then you have an NH2, or you have an amine in that position. So it could be an NH2, NHR, or NR2. So nitrogen with two alkyl groups. So an example of that would be something like this, NH2. That would be an amide, as opposed to an amine. Remember, an amine will be just like that. So this is amine. This here is an amide. The last group is acid anhydrides. Acid anhydrides have alkyl group connected to a carbonyl, and then you have something that looks like an ester on the other side, like that, with another alkyl group. So this is really an ester. So an example of an acid anhydride, but you can also have cyclic acid anhydrides. Acid anhydrides, they have carbonyl carbon, oxygen, carbonyl carbon. See here, carbonyl carbon, oxygen, carbonyl carbon. Same thing here. Carbonyl carbon, oxygen, carbonyl carbon. Thank you very much.